Hello, welcome to the session on design of machine elements 2, subject code 18ME62. So in this session, that is module number 3, design of bevel and worm gears, we'll be continuing to solve the numerical on worm gears. So next problem number 2. Design a worm drive for a speed reducer to transmit 30 kilowatt at a worm speed of 600 rpm. The required velocity ratio is 25:1. The worm is made of C30 heat-treated steel and the worm wheel is made of phosphor bronze. The service conditions are intermittent operations with light shock loads. Also calculate the heat dissipation through the drive. So here it is given that the velocity ratio is 25:1, so that's 25, and then the power is 30 kilowatt. So the worm is made of C30 treated steel, the materials are given, and worm wheel is made of phosphor bronze. The service conditions are also given, a light shock loads with intermittent operations. Then also the speed of the worm, that is N1, is 600 rpm. So we divide by 60, it will be 10 revolutions per second. That is n suffix small n suffix 1. So again, making use of the equation for the velocity issue, I dash is given by small n1 suffix small n2, that is equal to z2 by z1, and if we use this we can find out the value of a2, that is rps for the revolutions per speed in terms of the revolutions per second for the worm gear, so that is 0.4. So next is the materials. So here let us take the values of the stress for the given materials. That is for C30 treated steel, if you see that on the table 12.7, you have a stress value to 20.6 megapascal, and for phosphor bronze it's given by 82.4 megapascal. So as already stated, in the case of worm gear design, always is the worm gear is taken as the weaker member, so therefore the design is based on the worm gear. So therefore, coming to the first step, that is, so here in this particular problem, if we make use of this particular equation, because we know the power, but the center distance is not known in this particular problem, so therefore let us make use of this equation. So using this we can find out the center distance. So because we know the power that is being transmitted, we know the velocity ratio. So if we substitute these values, we get the value of the center distance small a as 438.35 millimeters. So let's approximate it to the 450, approximate it as 450 millimeters, since it is the center distance. Next step is to find the diameters. So in order to find the diameter, again we can make use of this equation. D1 is equal to small a to the power 0.875 by 1.266. Because we have found out the value of the center distance, substituting it, we get the value of D1 as 43.029 volts. That will be approximately to 150 millimeters. That is the physical diameter of the worm. Next, physical diameter of the worm gear is given by D2 is equal to 2a minus D1. This is using the center distance equation. So, substituting these values, we get the value of D2 as, that is the physical diameter of the worm wheel or worm gear as 150 millimeters. Next, coming to the next step, in order to find the module, we have the equation. In this equation, Ft is equal to sigma d into Cv into B capital Y to M. Equation number 1.53. So, before that, we can find out the velocity. So that is nothing but given by V is equal to pi d2 into by 1000. Is of this equation. So here, if we substitute the values of the diameter and the speed, so we will get the velocity as 0.9425 meter per second. So CV values, CV equation for CV is 6.1 by 6.1 plus B. So substituting the value of the velocity what we obtained, so we are going to get the value of CV as 0.8662. Now phase width is given by the equation 12.64 according to AGME is small a to the power 0.875 by 2. So that is if we substitute the value of the center distance given by B is equal to 104.84. So you can take it as nearly 105 millimeters. Next, coming to the equation for Ft is actually given by 2 mte over d2 into Cs, where Cs is the service factor. So it depends upon the service conditions. So now here KL is the load factor which can be actually taken from the table number 12.33. Here let us assume the load factor as 1. So CS is a service factor, but depends upon the service conditions. So therefore, let us refer to the table number 12.31 here. For the given service conditions in the problem of light shock load with intermittent operations, we can observe that the value of CS is 1.25 from the table. So next, coming to the equation for the power, it's given by 2 pi n2 into mt. So if we substitute the value of this, the power and the speed of the gear, so we can obtain the value of the torque. The torque value will be 11.936 into 10^6 Newton millimeters. So let us substitute this in the Ft equation. Ft is equal to 2 into mte. Mte is nothing but again 11. If we multiply this by the load factor, that is assumed as 1. So into the service factor 1.25 divided by the d2. That is the physical diameter of the worm gear. So we obtain the value of the Ft as 39,786 or 39.79 kilonewtons. So now let us refer to the table number 12.28b in order to find the number of starts on the worm, so that depends upon the velocity ratio. So from that table, if for I, that is I dash greater than 20, the Z1 value is 1. Now from table number 12.28c, so for the pressure angle of alpha is equal to 14.5 degrees, so the Lewis count factor small y is given as 0.1. So now let us substitute these things in the Lewis equation. So the value of the all these things if we substitute in the Lewis equation, including the stress sigma D2 for the worm gear, and the value of the CV, the phase width, as well as the form factor, that is Lewis form factor 0.1, we can obtain the value of the module as 16.90. It is coming as 16.90 mm. So referring to the table number 12.29, we find that the standard value of the module is, after 16, it is 20 millimeters. So therefore, let us take the since it is 16.90, let us take the standard value of the module as 20 millimeters. Next, coming to the lead angle, is given by the equation tan gamma is equal to m z1 over dy. So substitute the value of the module and the number of starts on the worm divided by the pitch circle diameter of the worm. So we are getting the value of gamma is 7.59 degrees. Next, to find the dynamic load using this equation 5.54, if we substitute all these values, the stress, phase width, the form factor, and the value of the module, so we are going to obtain the value of FD as 54,362.11 newtons. So this 54.36 kilonewtons. Next, to find the wear tooth load, we have the equation 12.62a, is FW is equal to D2 into V into K. So from table number 12.30, we can obtain the value of the load stress factor K. So that is depending upon the lead angle. Since the lead angle is within this range 0 to 10 degrees, the load stress factor is K is equal to 0.549. Next, we have the if we substitute all these values, we are going to obtain the value of the FW as 43,233.75 newtons or 43.23 kilonewtons. Since in this particular problem, if you observe, the value of FT is 54.36 kilonewton, FW is 43.23 kilonewton. Since FW is less than the FD value, so therefore the gear will be subjected to rapid wear, and hence it has to be surface hardened to the higher Fresnel hardness number. So since the always the wear load has to be greater than the dynamic load, so therefore let's substitute the equation for the wear load D2Vk should be greater than whatever the value of the dynamic load we obtained in terms of the newtons, 54.36 kilonewtons. So we obtain the value of K as it should be greater than 0.690 for this particular problem. So next is to find the efficiency. So again, when the worm is driving the worm gear, so we have this equation 12.57b, where tan theta is given by the equation tan alpha into cos gamma. So we substitute the values of the pressure angle and lead angle, we obtain the value of theta as 14.38 degrees. So coefficient of friction Q depends upon the rubbing velocity VR. So where VR is given by pi d1 n1 over 1000 into cos gamma. So substitute all the values. Then VR rubbing velocity is given by 4.75 meter per second. Also, the velocity of the worm is given by pi d1 n1 by 1000. Substitute the value of the diameter and speed of the worm. We obtain the value of V as 4.71 meter per second. Now, the coefficient of friction that depends upon the velocity here of the worm. So, if it is say less than greater than 2.75 meter per second, then mu is given by this equation. So since it is in this particular range greater than 2.7 km per second, I substitute the value of the rubbing velocity VR as 4.75 meter per second. We obtain mu as 0.0405. Next, efficiency is given by the equation cos theta minus mu tan gamma divided by cos theta plus mu cot gamma. So we have already obtained the values of the theta and gamma as well as mu. Substituting these values, we obtain the value of the efficiency as 0.7569, which is nothing but 75.69%. And next, we need to find the heat generated. So that is given by the equation 12.63a, that is Qg is equal to mu Fn Vr over cos gamma. So where Fn is given by this equation Ft divided by cos gamma to cos alpha. So substituting the value of the Ft and the angles, lead angle and pressure angle, we can obtain the value of the Fn as 41,462.37 Newton, which is 41.46 kilonewton. Now let's substitute this in the equation for heat generated. Qg is equal to mu Fn into Vr over cos gamma. So when we substitute these values, we obtain the value of the heat generated as 8046.36 watt, which is 8.046 kilowatt. So heat dissipated is given by Qd is equal to 1000 into kW into 1 minus efficiency. So if we substitute the value of the power in terms of kilowatt and the efficiency what we obtain, we can obtain the value of the heat dissipated as 7293 watt or 7.293 kilowatt.